Velocity is the rate of change of displacement. Acceleration is the rate of change of velocity. This leads us to the diagram below, and this diagram should always be in your mind when you're doing kinematics. I have acceleration, velocity, and displacement. Velocity is the rate of change of displacement. Acceleration is the rate of change of velocity. Therefore, when heading this way, we are going to differentiate. Remember, differentiation gives us rates of change. Since it's an opposite process, when you're going this way, you're going to integrate. So, velocity is the rate of change of displacement. Acceleration is the rate of change of velocity, which is the second differential of the displacement. Since integration is the reverse process, it stands to reason that velocity can be obtained by integrating acceleration. Displacement can be obtained by integrating velocity. Change in displacement. We can determine the change in displacement from the velocity function using the change in displacement is equal to the integral between time 1 and time 2 of velocity with respect to time. The change in distance, however, and refer back to the difference between distance and displacement, as that's the total distance travelled, we can determine the distance travelled from the velocity function using distance is the integral from t1 to t2 of the modulus of the velocity dt. If we think about a velocity time graph, let's say it goes like this, you get change in displacement because we know areas above would be positive, areas below would be negative. So if we just do the integral from here to here, these areas would cancel, and that gives us displacement. It's a bit like going that way and then going that way. If you take the modulus, what happens is the part of the curve is below the axis would reflect upwards, and you won't get this bit. So then your total area is all positive, and that's how you get the distance.